Welcome to solverfy.
Okay, we're told about a tank of water. And we're told that our tank is 2 liters, but is initially half full. So it contains exactly 1 liter. And that water enters the tank at a rate of 3.00 grams per second and leaves the tank at 5.00 grams per second. The first question is this process continuous or batch? Well, remember that an important definition of continuous is that there is no designated start and end, or end, I should say. No designated start or end. That is, you cannot look at a continuous process and say it takes 2 hours or 5 hours or any given time. Continuous processes run until you stop them. In contrast, batch processes have a discrete beginning and end, right? So you can say, oh, when I make this molecule, it takes 3 hours to run the process, right? So by that definition, if we know that this tank will initially drain, as the problem statement states, and that we can calculate how much time it takes, this must be a batch process. So A is batch. And the second part is this transient or steady state. Okay, and this is in reference to the state of our system. That is, do we have a consistent water level? That would be steady state. Or does the water level change over time? That would be transient. Now, it's not always about water level. It can be about concentrations of reactants and whether they remain constant or change. But in this case, our only variable here is water level. And we know for a fact, again, by the fact that eventually the tank will drain, that property is transient. And so our process then is considered transient. We have a transient batch reaction. Okay, finally, we need to determine how long it will take the tank to drain completely. And the best way to do this is to set up an equation that describes the volume of water in the tank at any given time. And before we can do that, what I would point out is that we are given the initial water level in liters, while we are given the inflow and outflow rates in grams. We want to convert these to a like unit, right? And so one way to do that is to convert our tank volume into grams as well. If we permit that water weighs 1,000 grams for every liter or a kilogram for every liter, then we have that we are saying our initial water level is 1,000 grams. Okay, from here we can write an equation that describes our situation, right? The volume of the tank at any given time, right, from the start of our process is going to be equal to the initial volume, 1,000 grams. And then we're going to gain 3 grams per second. So let's say 3 grams per second, and that will happen every second. So let's say that's multiplied by time, t in seconds. And we're going to lose 5 grams per second. So minus 5 grams per second. And we'll multiply that by t, right? Because that will tell us at time t how many grams we have lost via this route. Okay, and what you'll notice is that we have like terms. We have 3 grams per second times t and 5 grams per second times t. We would combine those to get a final equation of 1,000 grams minus 2 grams per second times t. Now, we want to know when the tank is empty, which is equivalent of saying when does this equation equal 0, right? Because this represents the volume of water in the tank at any given time. So now our next step then is simply to solve for t. I'm going to add 2 grams per second times t to both sides of the equation to get 2 grams per second times t equals 1,000 grams. And then I'm going to divide both sides of the equation by 2 grams per second to get that t is equal to 1,000 grams divided by 2 grams per second times t. Our units will cancel nicely. Grams cancel with grams, and we're left with 1 over seconds, right, being in units of seconds, and t being in units of seconds. No, we did not divide over t. Sorry, we'll get 1 over seconds, which will give us our final unit of seconds. And so we will get t equals 1,000 divided by 2, and then units of seconds, or 500 seconds.